Hello guys, welcome to my YouTube channel. Today we will discuss about that how ChatGPT actually works. ChatGPT is the latest language model from OpenAI and represents a significant improvement over its procedure GPT-3. Similarly to many large language models, ChatGPT is capable of generating text in a wide range of styles and for different purposes, but with remarkably greater precision, details, and coherence. It represents the next generation in OpenAI's line of large language models, and it is designed with a strong focus on interactive conversations. The creators have used a combination of both supervised learning and reinforcement learning to fine tune ChatGPT, but it is the reinforcement learning component specifically that makes ChatGPT unique. The creator uses a particular technique that is called reinforcement learning from human feedback (RLHF), which uses a human feedback in the training loop to minimize harmful, untruthful, and biased outputs. We are going to examine ChatGPT's three limitations and how they stem from its training process. Before learning how all RLHF works and understand how ChatGPT uses RLHF to overcome these issues, we will conclude by looking at some of the limitations of these methods. In the context of machine learning, the term capability refers to a model's ability to perform a specific task or set of tasks. A model's capability is typically evaluated by how well it is able to optimize its objective function, the mathematical expression that defines the goal of the model. For example, a model designed to predict stock market prices might have an objective function that measures the accuracy of model's predictions. If this model is able to accurately predict the movement of stock prices over time, it would be considered to have a high level of capability for this task. Alignment, on the other hand, is considered with what we actually want to model to do versus what it is being trained to do. It asks the question, is that objective function consistent with our inventions? And refers to the extent to which a model's goals and behavior align with human values and expectations. For a simple concrete example, say we train a bird classifier to classify birds as either sparrows or robins, and we use log loss, that is, which measures the difference between the predicted probability distribution of the model and the true distribution as the trained object, even though our ultimate goal is a high classification accuracy. The model might have low loss. For example, the model capability is high but poor accuracy on the test set. In fact, the log loss is not perfectly correlated with accuracy in classification task. This is an example of misalignment where the model is capable of optimizing the training object but poorly aligned with our ultimate goal. Large language models such as GPT-3 are trained on vast amounts of text data from the internet and are capable of generating human-like text, but they may not always provide and always produce output that is consistent with human expectations or desirable values. In fact, their objective function is a probability distributions over word sequences, that is, or token sequences, that allows them to predict what the next word is in a sequence that is more detailed in the below.